Hello everyone, welcome to workbook. The question says, show that the middle term in the expansion of 1 plus x whole raised to the power 2n is 1 into 3 into 5 into up to 2n minus 1 divided by n factorial whole multiplied by 2 to the power n into x to the power n. So, given here the expression 1 plus x whole raised to the power 2n, and we have to prove that middle term equals 1 into 3 into 5 into up to 2n minus 1 divided by n factorial whole multiplied by 2 to the power n into x to the power n. Let's see how the proof goes. First of all, we have to find that this expansion 1 plus x whole raised to the power 2n has how many number of terms and which one is the middle term. Okay, so number of terms equals what and which one is the middle term. So for finding out these two, let me give a simpler example to you. Here is the example. We have a plus b whole square equals a square plus 2ab plus b square. A plus b is a binomial raised to the power 2, and likewise here the power or the exponent is 2. Here we have the exponent or power equal to 2n. Both are even. So here the number of terms are 2 plus 1, which is equal to 3. In that fashion, for this expansion 1 plus x whole raised to the power 2n will have number of terms equals 2n plus 1, which is odd, as 3 here is an odd number. So the middle term in case of odd number of terms will be the number of terms plus 1 divided by 2th term. So here the middle term in the expansion of a plus b whole square is 3 plus 1 divided by 2, which is equal to 4 by 2 equal to the second term. So in this case, where we have expansion of 1 plus x whole raised to the power 2n, we have 2n plus 1 number of terms, which is odd. So the middle term will be 2n plus 1 divided by 2th term, or which is the n plus 1th term. Now, as per binomial theorem, the general term or the r plus 1th term for the expansion of 1 plus a whole raised to the power n is given by NCR a to the power r. Here, in place of n, we have 2n, and in place of a, we have x. So, here, tr plus 1 for the expansion of 1 plus x whole raised to the power 2n will be 2n cr x to the power r. But we need the n plus 1th term, which can be found very easily by replacing r by n in the expression of tr plus 1. So we'll get tn plus 1 is equal to 2n cn into x to the power n. Okay. So this is the middle term of this expansion given as 2n cn into x to the power n. Now we have to manipulate this 2n cn into x to the power n to reach the final result, which is to be proved. Okay. Before that, let me inform you that NCR equals n factorial upon r factorial into n minus r factorial. So in that fashion, I will expand 2n cn. Okay. So tr plus 1 will be equal to 2n factorial divided by n factorial into 2n minus n is n itself, n factorial whole multiplied by x to the power n. Okay. So now I can expand 2n factorial as 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 up to 3 2 1 divided by, in the denominator we have n factorial into n factorial. This is whole multiplied by x to the power n. Now let me separate the even terms and the odd terms in the expansion of 2n factorial. So First, the even ones will be 2n into 2n minus 2 into 2n minus 4 up to 4, 2, and the odd ones will be starting from 2n minus 1, 2n minus 3, it will reach up to 3, 1, divided by, in the denominator we have n factorial into n factorial. This is whole multiplied by x to the power n. Now, if I factorize the even ones in the expansion of 2n factorial, then I'll get 2 times n into 2 times n minus 1 into 2 times n minus 2 into up to 2 times 2 into 2 into multiplied by the odd ones 2n minus 1, 2n minus 3 into up to 3 into 1 divided by, in the denominator I have n factorial into n factorial into whole multiplied by x to the power n. This is further equal to these 2, 2, 2 up to 2, 2. So I'll get n times 2, which is equal to 2 to the power n into n into n minus 1 into n minus 2 up to 2, 1 is n factorial into the odd ones remain as it is 2n minus 1, 2n minus 3 into up to 3, 1 divided by, in the denominator I have n factorial into n factorial. This is whole multiplied by x to the power n. Now 1 n factorial in the numerator and 1 n factorial in the denominator, when divide will give 1. So we will get 1 into 3 into 5 into up to 2n minus 3 into 2n minus 1 divided by n factorial whole multiplied by 2 to the power n into x to the power n. This is what we needed to prove. Hence proved. Hope you guys understood the explanation. Thank you.